This is a keypad voltmeter, which explores Kirchhoff's voltage law and the voltage division rule. As you can see here, as I click the different buttons, the green display will read different numbers. This digital display is a voltmeter, which measures the voltage from a certain point in the circuit. Today, I'm going to be explaining to you what happens here. This is the breadboard prototype of the circuit that you just saw. As you can see, there are 4 momentary push buttons: key 1, key 2, key 3, and key 4. 3 fixed resistors, 2 1K ohm resistors, and 1 4.7K ohm resistors. This breadboard prototype is based on this schematic here. As you can see on the schematic and the prototype, key 1 and key 3 are connected, key 2 and key 4 are connected, and there are different paths with each button you click, which allows current to go through with each button. And the different paths have different resistor combinations, which means with each button you click, there will be a different voltage reading. The circuit operates based on Kirchhoff's voltage law, or KVL. Kirchhoff's voltage law states that the sum of all voltages around any closed loop in a circuit must be equal to 0. This is another way of saying that before the power gets to the ground, the voltage has to be all used up by the components, in this case, the 3 resistors. And it follows this formula. Another concept used in this circuit is voltage division. When resistors are connected in series, the supply voltage is split across the resistors, and this depends on the values that they have, so 4.7 k ohms, 1 k ohms, and 1 k ohms. By changing the path through these different keys that we press, there will be a different voltage output that we can calculate with this equation. R2 will always be this 1 k ohm resistor in this case because all 4 buttons use this to get to ground. This device here is a digital multimeter, or a DMM, and is set to voltage so we can see what the voltage is when each key is pressed at this 1 k ohm resistor, the output. Key 1 only goes through this 1 k ohm resistor, and 1 k ohms divided by 1 k ohms times 9 should be 9 volts, which it is around here. Key 2 uses both these 1 k ohm resistors before going to ground, and 1 plus 1 is 2, so 1 k ohms over 2 k ohms times 9 should be 4.5. Key 3 uses a 4.7 k ohm resistor and this 1 k ohm resistor. And 4.7k plus 1k is 5.7k, meaning 1 divided by 5.7k is times 9 is around 1.58, which you can see it is here. Lastly, key 4 has all 3 of these resistors in its path. So 4.7k plus 1k plus 1k is equal to 6.7k. 1 k ohms over 6.7 k ohms times 9 should be 1.34. And you can see it is around 1.3, 1.2 volts.